Welcome to today's deep dive. So imagine you're watching like a live esports tournament. The crowd is screaming, the stadium base is literally shaking the floor beneath the camera, but on your screen, the giant digital dragon flying behind the players stays, perfectly flawlessly locked in place.
Right, it looks like magic, but you were actually watching a pretty wild masterclass in optical engineering and data synchronization.
Today, we are looking at the exact specs that make that illusion possible. We've got the product page from HDTVSupply for the Bolin Technology R9-230H FHD PTZ camera. And at $4,395, it is a serious piece of broadcast hardware.
Oh, definitely. It's a massive investment.
Yeah. So our mission today is to explore how this tech is quietly bridging the gap between traditional live television and the future of virtual reality production. Okay, let's unpack this. Looking at the hardware, they highlight a 30x optical zoom and this Japanese-manufactured Sony 1/1.8 type Starvis 2 sensor. I mean, I know Sony makes great sensors, but what does that actually mean for a live broadcast?
Well, it really comes down to physics. A 1/1.8-inch sensor is physically larger than what you'd find in a standard camera. And a larger surface area means it just physically captures more photons of light.
Oh, okay, so like a bigger bucket catches more rain.
That is exactly it. So when that stadium lighting drops unexpectedly, the camera doesn't produce this grainy, dark image trying to digitally compensate. It actually has the raw light data to see perfectly in full color.
Wow. Okay, I also see professional audio connections listed here, specifically balanced XLR inputs with phantom power. Does phantom power just mean it powers the microphone?
Precisely. Yeah, instead of the microphone needing its own battery, the camera sends electricity back through the exact same audio cable that's receiving the sound.
Yeah.
It really streamlines the physical footprint for the crew.
That makes total sense. Now, what about the shaking floor from our esports example? The specs mention a dual-level super image stabilizer. Is that just, standard digital smoothing?
No, not at all. Digital smoothing actually just crops the image to hide the shake, which throws away resolution. A dual-level optical stabilizer physically moves the internal glass of the lens to counteract the vibration.
Wait, really? So if the camera gets bumped right, the internal lens instantly tilts left?
You got it. Without it, the bass from those stadium speakers would turn a live broadcast into a blurry mess.
So it's essentially a mechanical shock absorber built straight into the optics. That's incredible. But having a perfectly stable, clear image of the physical world is really only half the battle here, right?
Right.
Because if we're putting these players in a virtual environment with that digital dragon, how does the 3D rendering software know exactly what the camera's looking at? I mean, if the camera pans or zooms, the virtual background has to scale perfectly with it, or the whole illusion shatters.
That is the exact problem this camera solves. And the bridge between the physical and the digital here is something called the Freed protocol.
Here's where it gets really interesting. I saw Freed in the specs, but I couldn't figure out the mechanism. Does it mean the camera is essentially talking directly to the virtual environments? Like, is it sending a video feed for the software to analyze and track?
It's actually sending pure math.
Oh.
Yeah, Freed is a data protocol. In real time, the camera is calculating its exact physical position, so its pan, its tilt, and the precise focal length of its zoom axis. And it feeds those raw numbers directly into the rendering software.
Oh, wow. So the camera isn't just capturing light, it's constantly broadcasting its exact physical coordinates. The software just automatically knows exactly where the camera's head is turned.
Right. It completely automates what used to be incredibly complex manual camera tracking.
Yeah.
And the R9-230H pairs this with AV over IP streaming.
AV over IP, meaning audio-visual over internet protocol, right?
Yes. Instead of running heavy traditional broadcast cables, the high-quality video and that free tracking data are sent over standard computer networks. This results in ultra-low latency. The delay between the physical action and the digital rendering practically vanishes.
That is wild. So the next time you are watching a highly polished live stream with a seamless virtual set, look closely at the background. You aren't just looking at good green screen work.
No, you're watching invisible, automated technology doing intense mathematical heavy lifting in real time. We really have moved from simply capturing reality to actively syncing it with programmed virtual space.
Which leaves a pretty wild thought to mull over. If a camera today can flawlessly map and automate spatial tracking into a virtual reality space without missing a millisecond, what happens when this level of intelligent, automated spatial mapping shrinks down?
That's a great question.
Right. Imagine that unblinking, hyper-stabilized lens making its way into the everyday consumer devices sitting in our living rooms. The line between your physical home and the digital world might just disappear entirely.